Hello everyone, my name is Matt Vernon and I'm a computer engineering student. I'm going to be showing you my procedural shape generation project for my engineering 2304 class. This program was made with MATLAB and all the files for this project, including the design document, can be found on GitHub. This is the README file. It gives a brief description of the project, lists which packages must be installed to run the program, the sources used in the project, and what I wanted to add to the project if I had more time. This is the design document made for the project. It covers the requirements, explains at a high level how the requirements will be met, how the project will be designed, and recommendations for things that were out of the scope due to limited resources. For the sake of time, I will only read the introduction. By using the concept of procedural generation, this MATLAB program will allow the user to specify certain parameters, such as noise layering, amplitudes, frequencies, resolution, and size to generate unique shapes. Procedural generation is commonly used because a computer can generate organic and natural looking shapes much quicker than someone can model them by hand. This process is useful for 3D simulations, animations, video games, and anywhere that computer generated shapes could be useful. Because of the heavy computation times of procedural generation and noise generation, this program will utilize MATLAB's GPU array capabilities wherever possible. Initial tests have shown that matrix calculations done on the GPU are 100 to 200 times as quick as those done on the CPU, although the program will be built to work whether the user's computer has a GPU or not. This program uses a cube sphere as the starting shape. A cube sphere is a type of sphere that has even distribution for all vertices and offers linear control for the number of vertices. It consists of two functions, one that generates vertices of a cube for a given resolution value and size value, and one that takes the vertices of the cube and forces them into a spherical shape. Because of how MATLAB renders surfaces for vertices, I found it easiest to create the 6 faces of the cube separately and then combine them to form a cube. Once the cube was made, it was easy to transform it into a cube sphere. The math for converting cube vertices into a sphere is outlined in the design document. All user input and output is handled through one main GUI. The GUI has controls for noise, shape size, shape resolution, surface textures, and processor selection. When the user generates a shape, the shape will be displayed onto the same window. From here, the user will be able to save a generated shape for future use if desired. However, that feature has not been implemented yet. The GUI itself is resizable and responsive to different resolutions. Once the user clicks the Generate Shape button, all input values are sent from the GUI to the main program. From there, the main program uses the input data to create a cube sphere of the set size and resolution. Then the program will add noise according to the set input values. This is where the shape gets randomized features instead of simply being a smooth sphere. Since the shape is not actually one complete mesh, but instead 6 separate sides of a cube, after adding noise, the shape will become separated at the seams. Because of this, there is a separate function that realigns the edges of the 6 faces to create one solid shape. After all the calculations are done for generating the shape, it must be displayed to the user. The render function is called and determines how the shape will be displayed depending on set input values. The rest of the video will be of running the program and generating different shapes. Thank you for watching.